Here we have a triangular prism. The dimensions have been given to us, and we need to calculate the size of the angle between AD. So here is AD and the base ABEF. So I want to draw a line across that base, starting at A, ending up beneath D, like that, where this point here is going to be in the middle of F and E. I'm going to call that M for midpoint. And this is the angle we're trying to work out, the angle between AD and the base. So let me draw that triangle out in 2 dimensions. A, D, and this is the point M that I made up. Right, do we have any of these dimensions? Well, no, we don't have any of them at the moment, but we can work out some of them reasonably easily. First of all, the length from A to M. I can consider the little right angle triangle across the base like this. Let me draw that out. So this is point A, this is point M. This point down here is like the middle of A and B. So this would be 5, half the 10, halving this. From here to here, well, that's just 15. So we can work out A to M from here to here by doing a little bit of Pythagoras. So 5 squared plus 15 squared, all square rooted, gives 5 root 10. So A to M from here to here is 5 root 10. Next thing I'm going to do is I'm going to try to work out what DM is. What this is. Again, we've got a little right angle triangle here. So D, M, E. I know D to E is 12. And M to E, well, remember M is the midpoint. So that's going to be 5 because it's half of the 10, half of all the way across. So this is 5. So again, a little bit of Pythagoras here. 12 squared is the hypotenuse minus 5 squared, all square rooted. Which is root 119. So that's D to M. And now we can do some SOHCAHTOA. The root 119 is the opposite. The 5 root 10 is the adjacent. So tan theta equals the opposite divided by the adjacent. Do tan inverse. And we get our answer, which is 34.6 degrees.